What is light? Light is what makes us see. It is energy. It is life. It travels at an enormous speed of 3 times 10 to the 8 meters per second. We explained in our previous video of how we can see, and we established that what you see isn't matter. It is, in fact, the light that is bouncing off that matter. Light is produced when an electron excites to a higher energy level, and after some time, when it feels like returning to its preferable low energy state, it releases a photon. Isaac Newton theorized that light was made up of corpuscles, which are particles, but Christian Huygens and Thomas Young theorized that light was actually a wave. This was after he did the double slit experiment, where a beam of light was diffracted through and the interference afterwards produced fringes on a screen. Scientists became puzzled about the theory because what is it, a particle or a wave? Some years later, a concept of photoelectric effect showed up. This theory showed that when light was intensified, it knocked off electrons from the surface of a metal. Increasing intensity was supposed to have increased the speed of the departing electrons within the metal, but this, instead of increasing the speed, increased the amount of particles being emitted. More energy should equal the increase in the departing kinetic energy, but the frequency rather increased the speed of the electrons, whilst the intensity didn't. Now, frequency is the number of oscillations made in 1 second. And intensity could be defined as the magnitude of waves per unit area. Albert Einstein, who is known for this theory, solved the puzzle by deducing that light traveled in packets called photons, which earned him a Nobel Prize. Sending more of them, thus increasing the frequency, was the only way to increase the energy going to the electrons. Yeah, for light, I think we should revisit the definition of intensity again. Light was then taken to be a particle and a wave at the same time. Yeah, but is it? Wave particle duality. Well, let's introduce an interesting concept, a mind-boggling concept of the three polarizer paradox. When light is sent through two polarizers placed perpendicularly to each other, light doesn't pass through them. Thus, you don't see any light behind the second polarizer. But when a third polarizer is placed between these two polarizers, angulated at 45 degrees, then some amount of light passes through all three, and this is a mind-boggling concept for physicists around the world. The Bell's theorem explains that there is no physical theory for local hidden variables which can produce quantum mechanics predictions. What this means is that properties of particles are non-local, and thus are too far apart in space and too close together in time that it would take more than the speed of light for an interaction between particles to occur. Thus, they cannot be observed and understood. Well, we have a Bell's theorem situation here where the light passes through the first polarizer. There is a 50% chance light photons will emerge on the other side, and these photons are polarized in such a way that the second polarizer wouldn't allow any of these photons. But when a third polarizer is introduced in the middle, the light seemingly reorients itself and then increases the probability of emerging at the end of the third polarizer. Light is quantum, and this is more probabilistic than deterministic. Another interesting theory is when we revisit the double slit experiment again. When a single photon this time is passed through the slits, this photon, if a particle, as we have been made to understand, should be passing through one of the slits and then emerging on the screen as a single point. But what happens is that it passes through both slits and then interferes with itself and therefore forms fringes on the screen. How? The answer to this could be that when the light was moving and with its speed known, an observer, according to the Heisenberg's uncertainty principle, should not be able to observe the position. Therefore, the single photon is non-local. Thus, it is in all those positions at the same time. Wow. Light could be a wave or a particle, or it could be its own quantum particle obeying or undergoing its own quantum laws. After all, photons are the only particles without rest mass, but they have energy and momentum. Every object in the universe radiates photons. Light also transfers information. To blow your mind some more, we have already established that photon is what mediates electromagnetic force. And since electromagnetic force is present in all atoms, like I said from the beginning, we are alive because of light. Everything exists because of light. Light is life. So to answer your question of light, light is everything we see, everything we are. Light is everything. Thanks for watching. This is Einstein in the Flash. Like and subscribe. Goodbye.